Thank you for joining Cloud Agnostic Intelligent Edge. Please welcome Insight Senior Architect, Ben Kotvis.
Welcome, everybody. This presentation is about Cloud Agnostic Intelligent Edge. My name is Ben Kotvis. I'm a Senior Architect for Insight's Digital Innovation Group. So today we're going to talk about cloud agnostic solutions on the edge. And I have kind of a cute quote here by Alan Deneau that says, if you believe in the cloud, you can't be agnostic. So that's a little tongue-in-cheek for this presentation. And I did that on purpose because, you know, with Edge, we're not really talking about a solution that's, you know, completely running in the cloud. Just certain pieces of it are going to rely on the cloud. So our goal is to find out what those pieces are and be able to build a solution intelligently that can run and be kind of swapped in and out without having to, you know, be rewritten or reworked. So let's talk about concepts that we're familiar with, like flexibility and hosting in a cloud solution provider. So when we think about cloud solution providers, we're thinking about potential off-the-shelf prescriptive solution options. So we'll have, you know, potentially, you know, let's say just a web-based application that we want, and there's a number of different pieces that we can use to solve those problems. Often there's going to be prescriptions about which resources we use, why we use them, and how we put them all together. And so when we think about those, you know, providers, a lot of times these are prescriptive solution offerings that are somewhat bundled together. They can usually run independently as well, but they're often bundled together with kind of a prescription about how you would build your solutions. There's also operational and provisioning capabilities. So you can, you know, onboard your solution through, you know, some DevOps pipeline where you can compile your code and you can distribute it to resources that are running on cloud, on the cloud. And so these are often kind of bundled in with cloud solution provider offerings so that you can easily deploy your code to those resources and get things up and running reliably and consistently. Often there's consistent APIs and SDKs so that when you want to interact with those resources, they will you know, be easy to use, and you're going to have a variety of different, you know, language options such as Java or .NET or Python, where you can interact with their APIs relatively easily without having to necessarily understand a lot of specific implementation details of you know, of their resources and of their solution services. There's a balance between flexibility and maintenance. And what I mean by that is that you have, you know, a resource where you're going to, let's just take an example of in Azure, you have an app service. So you can deploy your binaries to that app service and it'll run your code. You don't have to worry about operating system updates to continue, for that to continue to run. You don't have to worry about patches. You don't have to worry about security. That's kind of all handled for you. And that's you know, going to provide you some flexibility and ease of kind of deploying things. It's easier to maintain. You don't have to kind of keep track of the operating systems on all your servers or your VMs. So there's a really you know, nice kind of turnkey solution that you don't have to spend a lot of time worrying about some of the more finer details of running your solutions. But with that, you sacrifice some flexibility. You might not have access to every file on the operating system. You might have to kind of learn some of the implementation details that they've abstracted from you so that you can continue to run your solutions. And you may have to make adjustments to your solutions to run them that way. And so when we think about different examples of that, a virtual machine is really giving you maximum flexibility. You can, you know, kind of do most of the things you could possibly imagine, where PaaS, which stands for Platform as a Service, those are solutions where you have the ability to, you know, kind of spin up those resources easily, but you have less flexibility. You have less control over every aspect of it. And so when we talk about the cloud service providers, you know, that's really what they offer compared to some hosting on-premise, where you really have maximum flexibility. You have as many virtual machines as you can, you know, imagine running. You can spin up a dedicated physical machine if you want for certain workloads, and you can run them, you know, side by side. You can build new data centers, add new buildings. You really have maximum flexibility and maximum control because you own everything. And if you don't own it today, you can buy it and own it tomorrow. With that obviously comes, you know, some cost, but you do have control of pricing. You can, you know, make adjustments to the way things are implemented so that it costs you less money. No one's going to put price increases on you, so you have some kind of control over that. And you have an a la carte set of options that you can, provide best of breed services. If, for example, if one cloud service provider has a great offering here and another has one over here, it may not be that easy to make them work together. And so when you're running on premise, you have a lot more flexibility to do those things on your own. So when those are some of the differences between kind of what we think about when we think of cloud service provider offerings and then hosting on premise. The reason I'm talking about that is because the edge really is on premise, and that's really going to have all the same concerns of on premise hosting or having a data center on premise compared to the cloud. And so we have to think in terms like that. So when we think about some of our general concerns in hosting any solution, here's what we have to think about: security, scale, interoperability, and maintenance. So from a security standpoint, obviously, we need to think about is my hosted solution providing the appropriate level of security for my data? There's maybe a misguided notion that if you're running something on premise, because you physically have control over the data, you have control over people's access to it, and that is true to some extent, and maybe not always in every extent. In the cloud, you don't have physical control of where your servers are running and where the data is physically hosted. So you have some concerns about, who has access to this, how could they, how could that access leak to somebody else? So those are generally concerns when you're hosting any solution that you have to think about. You have to think about, holistic security solutions that can be integrated into the infrastructure. So like if you're thinking of something on premise, it may be like Active Directory domain controllers, or if it's Azure, you might be thinking of Azure Active Directory, where, you have the ability to communicate from one server to another using like a service account or service principal, where they can communicate within the context of the same identity between services, and they're all known as the same identity. And that's an important piece of every solution that's out there. And so those are concerns we have to think about. From a scaling standpoint, what if I need to add more scale? That's just a basic underlying concern that you have. How do you adjust the infrastructure if you want to meet those needs? You just need to upscale, add more virtual machines in a kind of a traditional distributed computing scenario, and kind of load balance those servers. And then when it does come down to kind of optimizing those, the details of that scaling, how do I maintain the definition of that configuration? Are those in files and configuration, or in source control? Are those living in a cloud service provider's configuration, or is it on premise somewhere in a PowerPoint or a Excel file? So we want to think about how we manage that, as well as how we can upscale and downscale resources as we see fit. I mentioned interoperability a little bit from a security standpoint, but then in general, can I interact with other solutions and other services within the solution easily, or is it going to be a lot of work for them to understand how to communicate with each other? Are there kind of plug and play mechanisms and modular components that can help them kind of interoperate, or do I have to build all of that from scratch? And then, more importantly, does my source code need to specify those provider details? And then lastly, as we talk about maintenance, I mentioned this a little bit before, of operating system patches and updates. Is that something I have to be concerned about, or can I delegate that off to a cloud service provider? And then do I have staff that can manage those particular details? So now I'm going to highlight the things that we think about when we're doing edge hosting and some of the concerns. Ironically, the list is basically the same, and that is by design, because we still have to think about all the same things. One of the things that's maybe a little different is in the scale. On the edge, the idea is that you're going to kind of have a finite set of resources on the edge. You're not going to just have a huge data center in most cases. In some cases, it may be appropriate to have a small data center on the edge. But in general, these are going to be smaller installations, because it's going to be a targeted set of needs that you need, a targeted set of workloads that you need to run on the edge, that's closer to the people that need it, or closer to the devices that need it, and not just everything running on the edge, because then that's just an on-premise data center. So we're trying to balance those needs intelligently, and that means that we have a finite set of resources that we're working with. And we have to think about that when we upscale and downscale, and obviously when we build out the solution in the first place and we select hardware and we select resources. So this illustration is kind of a cloud solution provider specific architecture that I would typically put in place for an intelligent edge solution. So on the left, we have some cameras and we have some RFID readers, and those are connected to an edge gateway, and that gateway is responsible for doing some work and then forwarding some of the information off to the cloud. On the left in this client site, you can see pretty much everything is running independent of the cloud until you start getting into these lines that are connected to either IoT Central or IoT Hub in this particular example. And so, there's a finite set of things that we need to, really think about when it comes to integrating specifically with an implementation from a cloud provider. We don't have to, not every piece of the code, not every piece of the solution is going to be specific to it. So when we talk about, being able to be agnostic, we need to deal with these lines here that are pointed to the cloud, pointing to the right. And we need to figure out a way to abstract that so that we're not tied into one cloud provider. And so this is an example of what these often look like. So I'll talk about our goal before we move on to kind of the next step of this. And that's really to be able to build a solution that can run from on-premise to a cloud solution, and then back to on-premise without a significant rewrite of your code and your deployment pipelines. And so that's kind of our underlying goal when we talk about being cloud agnostic. So when we reinvent the solution, we have to think about decoupling from a cloud solution provider. I think in the early days of cloud solutions, we often just were happy to have a way of solving problems that was really less work for us. And so we were happy to couple things into the cloud SDKs, and we didn't necessarily put a lot of thought into being able to make those things distributable and kind of decoupled and more easily deployable to other providers. When I talk with clients, I find that often one of their concerns is the adaptability and flexibility of these solutions. They want something that can run in other places, and they want that flexibility. So, we need to think in terms of that as a provider, that we can build solutions that way. So when we talk about coupling, the areas that are often going to be coupled are going to be software development kits. That's what SDKs stand for. APIs, access programmer interfaces, and packages, and these are really the code pieces that we use to interact with those providers. And so that is often going to be, obviously tightly coupled into those implementations. We have to think about provisioning, and that means, onboarding devices, but that also means, onboarding code onto those devices and to, the edge gateways and the rest of the solution, frankly. Sometimes there's database query languages that are going to be specific to each provider. And that would be, something like, like a NoSQL database might have a different implementation of the actual query languages from some, standard like SQL language that's kind of abstract or generic. And then we have infrastructure as code. So you have your definition of your infrastructure and the scale related to that, communication between that infrastructure, configuration. When we talk about infrastructure as code, often that's going to be coupled into a specific cloud implementation. And then your DevOps pipelines. As you can imagine, you've got code that is going to be distributed to a specific resource. And so when you talk about maybe like an Azure function or a Lambda function in AWS, those are going to have to know I'm targeting this particular piece of or this resource in a cloud solution provider's offerings. And so those have to be defined there. So first steps for that decoupling is to consider the coupling during the design and implementation. We'll get into a lot more detail on that in a moment, but we have to think about this early in the design phase and think about, okay, what are the real concepts that we're after here and design to that. We want to create abstractions for those SDKs and APIs where the coupling would normally exist, so that we're not, just building out and just using those SDKs everywhere in our code base, but we're actually building solutions that are thinking about the concepts and abstracting out the details about the implementation. We can use resources that are less coupled to hosting providers. So if we need to do, messaging between, containers in Docker or something like that, there's solutions out there for that aren't necessarily specific to an implementation in the cloud, and so we can use that, and then our solution is agnostic. And so that's there's solutions like Dapper, and I'll talk a little bit more about that in a bit, that can help provide that that decoupling and that kind of cloud agnostic implementation that we're all after. And then some of the service offerings that are available are, going to be Docker, Kubernetes, Databricks, SQL Server. These are common things that you could use in an intelligent edge solution that would not be specific to a cloud implementation that you would find can run on premise, they can run on cloud implementations. And so the code that you have that might be interacting, or configuration you might have for, Kubernetes or Docker, would be indifferent of the underlying details, and they should run in any, on any implementation or any provider hosting offering. This is a architectural, and this is really a code architecture of a solution we built. And I wanted to outline this because it really illustrates, the implementation details and the concerns you have when you are designing these things. So in this particular case, there was a thermal camera that was ingesting data, and the camera was what I call a smart camera, where it was actually providing inferences to you. So you just needed to be able to receive the payload, and the payload was really giving you the information you needed. And so from an implementation detail, you needed to put up an endpoint that could receive HTTP requests, and then you had to process those. And so from that implementation, there's really nothing about the cloud there. If you wanted to host that on premise, or you wanted to host it in any of the cloud provider implementations, you could do that without really making any adjustments to this, because that is, HTTP is something that's between the camera and the intelligent edge. There's no implementation specific details that are specific to a cloud there. Then you also have direct methods. In this particular case, you have an edge hub, you're scheduling data, you have to start these things up, onboard them, secure them. And so those are specific details that you have to think about how you're going to interact with the cloud provider's offering in order to do that. And so on the left, there are some concerns we have that are going to be specific to a cloud. On the right, we also have some concerns that are specific to cloud, particularly IoT edge and storage. Those are concerns that have some specifics that are integrated into a cloud provider. And so when you think about it, what we have in the middle here is a lane where everything here is agnostic of the implementation details. It's just about the solution. So we have these jobs. It's an implementation detail I like, where it's just basically a background routine. And there's a number of different ones that, health about a camera, payload handler, restarting a camera, subscribing to the actual feed from the camera based on the inferences that it's gathering. And so these jobs represent the actual things that my solution is doing. And so what I can do is put everything about the solution in that lane for those jobs, and then I can build automated tests around those. And so all I have to do is be able to abstract out the services into interfaces using a concept called dependency injection, where my jobs are basically given something to call in order to interact with those other services. But when I test them, I'm faking all of that data, and I'm faking that implementation, so that when the job runs, it is getting a known input and a known output, and then my test can pass successfully. That way I can assert the quality of my code on a regular basis. But if I need to swap something out to target a different cloud implementation, I can do that on the right and the left, and everything in the middle stays the same. And so this is an example of how to build a cloud agnostic solution where your code is not getting the specifics about those implementation details, at least not the core of the code. But you still have those concerns you have to deal with, but you've kind of abstracted those out so that they're in a very specific part of your code, and they're fairly easy to interchange as needed. Some of the other areas that we have to think about that are going to often be affected by the cloud implementations are state management. And what state management is that you may have something like on or off that you want to control on a particular device, and so you want to be able to adjust that. And you want to be able to communicate that to the device and have the device actually communicate actual state back to you. So that's something you have to think about how that's going to be implemented, and then how you abstract that in order to make an agnostic solution. Messaging on any kind of IoT solution, you're going to have messaging. So you're going to be sending messages somewhere, receiving messages from a source somewhere, and so you need to be able to be, decouple that from the implementation details of the cloud providers. And so you always want the concept of messaging, but you don't want the implementation details of the cloud provider there. And then from provisioning, this is probably the most difficult part of it because there's a lot of security involved in provisioning, and often that's going to be specific to the cloud providers. Now, often these are going to be using certificates. They're going to be using something like a trusted platform module or hardware security module that will help provide security and guarantee that no one is pretending to be you when they onboard a device. And so those are areas where you have to consider the cloud implementation, but the concept is still the same. And so when you deal in concepts, you can kind of abstract often big parts of that and reuse it in between any type of solution for other types of hosting providers. So we'll reimagine some of the solution as we talk about operations and how we're going to put all this together when we do have to deal with the specifics of the cloud implementations. So what are the components of an edge solution? So when we talk about the intelligent edge, we have to think about the runtime, and that's going to be, the operating system. Are we running on Linux? Are we running on Windows? Or are we running on, some Cortex A series device or something like that? We have to think about what the runtime is that we're going to be running on. Is it going to be IoT Edge? Is it going to be, Docker? Those are some things we need to think about. We need to think about, how things are going to communicate with us, like sensors or cameras. We need to, those are, obviously core components because the data that you're receiving in the intelligent edge is, that's the whole point of building a solution for that. You want to be able to kind of broker communication between sensors, cameras, and, other integrations in the cloud. You have to think about code. I mentioned the different language opportunities there are in many of these providers. You can, build things in Java, C#, or Python. There's a lot of options. Provisioning, we've talked a lot about that so far, but that's your ability to kind of onboard the device and securely into the cloud platform. There's the device itself and the physical device, and you have to think about electricity. You've got to think about things like memory and processor power and things like that, cooling. You have to think about all these things when you're developing these solutions. And then from a DevOps standpoint, you have to be able to distribute the solution, putting the binary, essentially compiling the binaries, and then being able to push them out to the appropriate cloud resources. And then ML ops, when applicable. When we talk about intelligent edge, a lot of times we're talking about being able to kind of deploy trained models out to devices that they've been trained in a cloud provider, but then you have to be able to distribute a smaller trained version of that into your devices so that they can operate accordingly and as efficiently as possible. So some of the pieces that we're going to implement in order to provide kind of agnostic implementations are going to be containerization. So if you're not familiar with containers, those are going to be essentially a concept similar to virtual machines, where you have very, very small kind of application-specific computing modules that can really provide a specific implementation for solving usually a very specific problem. So an example of this might be MQTT broker on an edge, an intelligent edge solution, where you want to receive messages from some containers and send messages to another. You might have storage where you're going to store data like on a very small like SQL database or on the file system. Containers provide a lot of these types of solutions, and there's a lot of off-the-shelf containers available that are open source and available to use, so you don't have to build everything on your own. And so a good implementation is going to provide you the ability to use off-the-shelf containers as well as building your own containers and implementing them and deploying them with a kind of a host of combinations of whatever you need, to solve the problems that you need to solve. Part of what those implementations have in them is is version management, so you can onboard an older version of that particular container or a new version of that particular container image and roll them back as needed, which in any solution is really powerful to be able to kind of run those things and kind of adapt the solution on demand. The good solutions should also provide you the ability to kind of make adjustments to those versions from, remotely from the cloud or from on-premise in a central place that you can say, hey, I need to update the version of this particular container for this particular, device, and be able to do that without having to physically be on the device or on the same network as the device in some cases. In addition to that, when you think about containerization, you have to think about dependencies. Do you have any kind of dependencies on the operating system or on other containers and the versions of those containers? And so there's interdependencies that you have to think about, but containerization really makes a lot of that easier because you're not depending on the host operating system, you're depending on the container's operating system. And so when you build a container, you actually are defining, okay, I need this to be a base container image. And in some cases, it could be on Linux with Python already installed on it. In some cases, you might just specify Ubuntu as your operating system, and then you might apply a Python to it on your own. And so you have a lot of flexibility on that when you build out these containers, and you can specify dependencies during the build of those containers. And then from a networking and communication standpoint, within these container ecosystems, something like Docker or IoT Edge, which is essentially just a implementation of Docker, you have the ability to communicate within that network without having to expose things outside of it. So you could have an intelligent edge solution with, in some cases I've had 15, 20 containers running. They can communicate amongst themselves, but I can't actually communicate into one of those containers because it's a private network inside of Docker. So I don't have the ability because I didn't expose the port externally, so I can't actually communicate inbound to those containers. And so there's a lot of kind of flexibility around that. But what's nice about that is during your build and kind of development cycle, you can use those networks and build out your kind of container communication ecosystem. And then when you deploy it, it works exactly the same way because it's using the same technology, the same philosophy. So there's a lot of power in containerization, and basically all the intelligent edge implementations are going to use them because they're so flexible. Storage is another concern that we have to think about. And when it comes to kind of building these out, you want to make sure that you have rolling logs. You can't, it's with a finite set of resources, as I discussed, in previous slides, you have to think about storage. And, if I've just got logs, just accumulating tons and tons of data, eventually it's going to brick the device and the device isn't going to be very useful. So you have to be able to kind of have a policy where you're, essentially getting rid of logs every so often so that they're not filling up your hard drive. The same goes with, as we talked about containerization, we have to think about the images of those containers, because if you continue to roll images over and over and over again, the old images are going to stay on the device unless you are actively pruning them. And then for the volumes associated with those containers, this is usually less of a problem, but those can be kind of big. And as you have a lot of containers, and maybe you kind of deprecate a particular container, those volumes will still stay on the hard drive, and so you may have to prune those. A lot of times solutions aren't going to be changing the container needs that often, so it's not too big of a deal, but just keep in mind that you have to be cognizant of storage and conscious of the consequences of not taking care of that. From a development standpoint, we need to think about registry management. And what that means is when you build a container, as we talked about earlier, you need to put it somewhere so that it can be distributed in a central place to all of your intelligent edge solutions. So there's the Docker Hub that's available on the Docker Hub in the internet, which is kind of where you'd find most of the off-the-shelf containers that I talked about earlier. But in addition, the cloud service providers often give you the ability to host your own private registry kind of their resources. But you can also, put a virtual machine together and build it yourself if you want. So those are always options that you have. And when you push the containers out to those registries, that gives you the ability to distribute them then to your devices on demand. And that's an important part of a powerful, edge solution. From a DevOps standpoint, we have build and release management. So I need to compile my solution. So I need to compile my source code. In some cases, I need to actually build a Docker image out of them, and I'd say most cases. And then I need to be able to push them out to the registry we just talked about. And then I need to be able to just deploy a configuration or manifest out to the device so the device knows which versions of those container images it needs to run. And so that's really part of that DevOps process, and a really powerful, important part of that, where you need to be able to kind of push releases out to different devices in an easy way. And so DevOps is really the way to do it. And it's not unlike normal development processes, other than this kind of registry management that you have to think about. And then lastly, being able to test your solution. So we talked about kind of testing on that diagram where I showed kind of the decoupling. Well, being able to test that during kind of the development phase and then in your DevOps pipeline to validate that, somebody didn't erroneously check something in. Most of the DevOps tooling these days have the ability to run automated tests. And so it's really important that you can do that during your build and release. Normally after you compile, you're going to run some automated tests to validate everything is correct before you push any releases out. And so that's kind of part of your DevOps process. And then lastly, from an ML operations perspective, we have to think about how are we going to train our models. So the long-term management of these is really important. If we build a solution that's, let's say, detecting whether I'm, holding, a cup of coffee or something like that, that may be really good one day, but there may be discrepancies in that model. And so as time goes on, we may start to detect what those discrepancies are, and we may want to, make adjustments to that. And so sometimes we may feed in, a random sample of images that are coming from a camera feed, and then we may want to retrain those models later. And that's an important part of an intelligence edge solution, is the ability to kind of retrain and constantly adjust and fine tune our AI models. After we've done that fine tuning, we need to validate those models are actually behaving and providing the outcomes that we're looking for. And so that would, be something that you might do during, the DevOps pipeline, using some automated testing to say, hey, am I getting the outcomes I need from this model? Maybe feed in some images and validate that the images are coming out with the appropriate inferences, so that you can make sure that your intelligent edge solution is going to behave as expected. And then deploying those ML models. It's a similar, kind of concept to containerization, but usually it's not the same. You can use a container to deploy an ML model, but often containers can support more than one ML model at the same time, and sometimes you want to use them simultaneously. Intel's got a great platform called Open Vino Model Server, where you can actually run on the same, container in Docker. You can actually run the same model, but different versions of that same model side by side, just based on calls to that container. You just basically specify which version of that model you want to run. And so these are some of the things we have to think about. I've outlined from a training standpoint, because training is one of the core things on an intelligent edge solution that we're going to need the cloud for, or I should say the cloud or on-premise. And so when we think about what's not going to happen on the intelligent edge, it's going to be training, because that takes a lot of cloud resources, and often it may happen at certain times of the day. And so it may make sense to upscale compute in order to, deal with those higher workloads, and then downscale them when you don't need to have such high scale, so you don't have to spend as much money. And so I've kind of outlined a number of training solutions that are available. And so when you think about on-premises, you can use Databricks. You can obviously use whatever you want, because it's on-premise, you own everything. You can put whatever you want on there. But I'd say one of the biggest industry leaders right now is Databricks for kind of doing ML training. The cloud providers have a lot of their own offerings as well. So you'll see that Azure, Google Cloud, and AWS all also support Databricks. But in addition to that, there's Azure ML on the Azure side, Custom Vision. Google has AutoML and TensorFlow Enterprise. And then AWS has Recognition and Transcribe as some of their offerings that provide training in the cloud. So we're going to refocus and start to talk about, as I mentioned earlier, we want to really think about design and think about it in terms of cloud agnostic design. So when we start to build our solutions, when we design them, we have to design them, to be absent of the cloud solution provider specifics. We need to understand that some of the needs may be fulfilled by the cloud. So we have to kind of draw those lines in our mind and say, okay, we're going to offload this to something else. We don't know what it is exactly yet, but it's going to serve a certain purpose. And so the purpose of that is important. And that has to be part of your design, but the implementation details don't need to be at that point of design. Focus on the areas that that are going to be part of it. So we talked about state management, telemetry. We talked about training models. Those are areas of design that I'm talking about. When we ingest data from sensors and cameras, that should be done in a cloud agnostic way. We should be those cameras and sensors should be able to send us data without having to necessarily deal with a cloud implementation in order to do it. And then there's tools that we can use in order to kind of provide inter-container communication. They can receive data, with, they can handle some state management. They can handle messaging in a common way, such as like Dapper, which is an interesting distributed application architecture, and Kubernetes that can run anywhere and can run on premise. They can run in cloud solutions. They can run on the edge as well, and it provides a lot of power for solving those problems and answering some of those concerns without having any kind of implementation details that are specific to a cloud. And they're, in those two cases, those are open source, so they're fairly friendly to a lot of distribution options. So these are, somewhat repetitive to some of the other concepts that we talked about before, but I want to, just talk a little bit about some of the details about these. So from an upstream telemetry standpoint, the reason this is not, the implementation details aren't really important is because what underlies this is going to be often just MQTT or AMQP, which is in the industry standard in messaging. And so they having to deal with the kind of implementation details of a cloud provider isn't very important, because you have the underlying implementation that's going to solve the problem. So when you abstract these things out, as long as you're dealing with the core concepts, you're going to be covered. From a downstream messaging standpoint, often the implementation details of these are going to be that you're receiving an event somehow. And so most languages, most programming languages have that concept of being able to receive an event from something. And so your abstraction is going to have to deal with the event coming from somewhere. And then when you get to the specific implementation details, basically your implementation will have to provide the event so that your abstraction can handle that event. And so those are the ways you have to kind of think about it. In some cases, downstream messaging, really what that is from the cloud or from your on-premise solution, you're basically sending something to the device so that it can react immediately and take some action. And so those can be synchronous or asynchronous. And when I say synchronous, that means I need a response right now to know whether that was successful or not. Asynchronous means I'm just going to confirm to you that I received your request, and it will be processed later. From a state management standpoint, I mentioned before, that's basically like on or off. But there are different implementation details. Most of those are the underlying implementation is MQTT again, where you're basically sending a message saying, hey, somebody's asked you to handle state. The important thing is that the actual storage of state is not on the edge device. It's actually in a central place, either on premise or on the cloud. You basically have a consistent, reliable storage mechanism to say, hey, this is what the state of this particular device is supposed to be, and this is what I want it to be. So if that device has to restart, it knows what state it's in, and it knows what state it's supposed to be in, and it can do what it needs to do to get into the right state. So those are really important implementation details when you're dealing with any, kind of intelligent edge solution. And then lastly, from a security and authentication standpoint, this is obviously somewhere where you're going to be really somewhat more tightly coupled to the implementation details, but you can abstract out certain parts of that so that your business rules and your business logic is not necessarily concerned about those details. But in order to communicate to these solutions, you're going to often going to need security, because they're going to use MQTT or MQP over TLS, and you're going to need to be able to authenticate using a certificate or a trusted platform module in order to validate that you are who you say you are, and nobody can impersonate you and try to send information to your solution without being properly authenticated. So our results are going to be agile solutions. So this architecture that I've placed here, kind of provides this illustration of our concepts. We've got sensors and we've got cameras that are sending information to the intelligent edge host, which has these containers running inside of it. These containers are going to deal with certain concepts like state management, telemetry, security, ML processing, and downstream messaging. The cloud is dealing with things like telemetry ingestion. It's going to deal with integrations. It's going to do everything else, basically, or on-premise. That could, also be an on-premise solution. And then, being able to also do the ML training. And those are the implementation details and how they should be separated in your mind as you start to build out these agnostic solutions. This is going to provide a lot of agility so that this top layer can be swapped out without having to make a lot of adjustments to this middle layer. So what have we gained? Our solution now can run on-premise. We can kind of move it from the cloud back and forth without fundamental code changes. Our solution uses containers, and that can be deployed to solutions that may run on different cloud solution providers or on-premise without having to make any adjustments. Those containers are completely independent and self-contained and provide completely discrete operations on their own, and basically can interoperate with communication like messaging or HTTP or something like that. And so they're self-contained and agnostic of the implementation details of a cloud or on-premise providers specifics. Our design is focused on the problem space and not the specifics of an implementation. And then lastly, the solution is going to have a lot of agility and adaptability for the future. So that is the end of my presentation. Thank you so much for participating.